In 1957, Sandia Corporation established Tonopah Test Range in Nevada as a place for the Atomic Energy Commission to test ballistics and non-nuclear features of atomic weapons. 60 years and many upgrades later, the range has a similar primary mission: stockpile evaluation and R&D test support for the U.S. Department of Energy's National Nuclear Security Administration. Located 250 miles northwest of Las Vegas, the range covers about 280 square miles and includes radar systems, telemetry receive antennas, and 4 variants of optical tracking systems, all on 59 miles of new dedicated fiber optic cable to provide communication to and from remote instrumentation. Infrastructure continues to be improved. There are 2 main target areas: bunkers, a former mobile rocket launch facility, high bays, and housing. And although it's not apparent from the outside, inside these buildings are the latest technologies to meet today's robust testing challenges. 3 radars provide situational awareness information for aircraft safety and focus slaving data for instrumentation. Located on the west side of the range, they are elevated to provide maximum coverage and minimize the effects of ground clutter. Radar 2 is C-band with a 12-foot parabolic antenna that's hydraulically manipulated. Radar 3 is X-band with an 8-foot dish on an electric pedestal. Radar 4, another C-band, has an 8-foot dish and is also on an electric pedestal. Data from all systems is recorded at 100 points per second to provide quick-look positional information immediately following a test. 2 ground stations control 4 telemetry dishes on the range. The primary station at the control tower has 3 antenna dishes, and a mobile telemetry trailer with 1 dish is placed close to a target area. The newly upgraded stations include 10 dual tuner receivers for L and S band telemetry streams and 24-channel best source selectors. With 3 8-foot and 1 15-foot conical scan, all but one of the systems can auto-track on the RF signal of interest. Unclassified and classified data can be processed. Cine theodolites are one variant of the optical tracking systems that follow a test unit during a flight. Each of Tonopah's 7 cines can be placed at any of 16 surveyed locations, and each has been upgraded to be fully digital with an accuracy of approximately 20 arc seconds. When reduced, data from the instruments provides time-space position information at 10 frames per second. 3 telescopes can be placed anywhere on the range. The M16 Tracking Telescope, on a Sandia National Labs designed mount, has recently been upgraded and includes a high-speed digital camera behind a 117-inch Newtonian telescope. It provides event data at 100 frames per second and has a HD camera that's able to stream test video in real time. The RD1 tracking telescope, also on a Sandia mount, has been digitally upgraded for remote operations. It can accept 500 pounds of payload and may be used when additional sensors are needed or as a testbed for new technologies. The final variant is the Gimbal Tracking mount, designed for remote operations when a person on the mount is not possible. Tonopah's 4 GTMs can be placed at any of 11 surveyed locations, and each has 2 tracking cameras, 1 midwave infrared and 1 visible light. The systems also have 100-inch focal length metric cameras that can operate at 200 frames per second and produce precise time-space position information when the data is reduced. A worker can remotely control all mount operations from the Test Operations Center. All time-space position data includes weather information. RS-41 radiosondes acquire weather data at altitude, and the range is also equipped with ground weather stations. Solar-powered neutron detectors are available and have a 300-foot radius detection capability. The units are mobile and can be moved to meet customers' needs. Moving from the field to test operations, data and video from instruments across the range move along miles of fiber and enter the main distribution hub. Once inside, the information is patched and distributed as needed. 360-degree views are one feature of the recently updated Test Operations Center. The building's 4th floor contains 10 identical workstations that can be configured for the test director, flight engineers, and security, safety, and communications workers. During tests, the stations display real-time instrumentation data and video with sound. The 3rd floor has 7 workstations equipped for classified and unclassified operations. An observation room allows non-essential personnel to view test data and video in real time. The 2nd floor includes the Instrumentation Control station, all optical tracking mount remote operators, and airspace monitoring stations. 2 and 3D displays provide real-time views of instrumentation readiness and range airspace. After a test, customers are provided with initial time-space position information based on radar and non-corrected instrumentation pointing data. And within 2 weeks, the Cine and Gimbal mount video is reduced to provide true time-space position information. HD and high-speed video is edited to provide a full documentation of test operations. The range has a myriad of vehicles, equipment, and operators to recover test units. Trailers can be placed near impact areas, and excavators, drill rigs, cranes, graders, and water trucks are all available for a wide array of post-test activities. Celebrating 60 years, Tonopah Test Range offers state-of-the-art equipment and facilities, plus a dedicated staff to accommodate any mission that requires precision tracking and data collection for better information processing. Find out more at ttr.sandia.gov.